Alright, today we're going to be talking about limits and continuity. And what is a limit? A limit is basically when a y value in a function pretty much approaches something. And for example, when you're talking about a limit, as x approaches a number, it's always going to be a y value. It's never going to be an x value. And continuity is basically, can you draw the function without lifting up your pencil? That's just a basic definition of continuity and limits. And for a limit, for example, this limit as g of x equals 3 when x approaches 4. What would that be? Well, all we really know is that when the limit approaches x from the left side, which is what the negative means, and from the right side, which is what the positive means, it equals 3. That's the only thing that we can tell when we're given a limit like this, and that the y value is 3 as well. Alright, now we're going to look at an example of a limit. And we're going to look at a limit as x approaches 2. So we have to look at this from the left side as well as from the right side. So as x approaches 2 from the left side, which would be right here, since we're left of 2, the function is up here. So that means it would be 2. But then as the limit approaches x from the right side, which would be from this side, we are at 1. So that means it would be 1. And since these two are different, as x approaches from the left and the right side, that means that if the function does not exist. For the function to exist, these would have to be the same. They would have to approach x at the same point. For example, right here, this is not a limit, but this is the actual value. F of 2 equals 1, because if you go to 2, it would be 1 right here, and it's a filled-in circle. And that means that this would be 1. So the limit and the value are not always the same thing, because the limit does not exist here, since from the left and the right they are not the same value. But here, the value is 1. Alright, we're going to look at another example here. When f of 3 equals, well, when the value is f of 3, it does not exist because there's a hole right there. So when f is 3, or when x is 3, right here, it does not exist because there's a hole right there. The actual value does not exist. The limit, on the other hand, we would have to look at the left and the right side. So when the limit approaches, when the x value approaches 3, the limit from the left-hand side, which would be from here, is 4. So it would equal 4. And then from the right-hand side, it also approaches 4, because this is the right-hand side, and it's still 4. So since both of them are 4, we can conclude that the limit as x approaches 3 does exist, because it approaches 4 from both sides, the left and the right. And for example, if we go here, and we say as x approaches 4, then the limit is whatever this y value is right here. But the value is also the same right here. Whereas right here, the actual value does not exist because there's a hole right there. But the limit does exist, it is 4. But here, the limit and the value both exist at this point right here, this y value. So when is a function actually continuous? A function is continuous whenever you plug in a x value, it always gives you the same a value. For example, over here, when we plugged in 2 for the limit, as an x value, we got 1 and 2, so they were different. And because these values were different, it was not continuous. But when we plugged in 3 for the x value here, we got 4 both times for the limit. So it always equaled a, 4 was a, and it always equals 4 whenever we plug in the x value. Therefore, it is continuous. And for this part, if we know that g of x is continuous, then we can assume that the limit from the left-hand side and the right-hand side are the same. However, if it's the reverse and we do not know if it's continuous, and we have the left-hand side, we cannot just say that it's continuous because the right-hand side might be different. So you always have to make sure that you know the left-hand side and the right-hand side to determine if it's continuous. Alright, now there are several different types of discontinuities. And these two discontinuities right here are removable discontinuities, or holes. So in this discontinuity, when you look at f of 0, it would be, the limit would be 1, but the actual value is not there. So it would be discontinuous. So there's a hole right there. And right here, the actual value is supposed to be right here. Or no, sorry, the actual value is right there, but there is a hole right there, so it would be discontinuous as well. And that's removable because the value is up here instead of right there. Right here, this is a jump discontinuity because it jumps right here. So the actual value is up here, there's a hole right here, but then it jumps and then keeps going. This is an infinite discontinuity because there's no really hole, but there's no value right here. So it's not continuous. It's another discontinuity. And then oscillating is also a discontinuity as well, because it oscillates and it's not continuous because there's a break right here.
Well, you can tell by the way I use my calc, I'm a mathematician, no time to talk. Limit powers and lines, it all just comes to me. You would assume, well, don't worry, it's okay, I understand your ignorance. We can try to understand the derivative of determinant. The moment you're ready, need to look to run, stay alive, stay alive. Use a Russian can add by economic to the right, gotta derive. Gotta derive, gotta derive. We can derive. The same man, jump around. The entertainer grants his news to the information I will lose. Now it's all around. It's okay if you can't find us at central age. We can try and understand the gravity of third-time man. The woman you heard and you can live until life and stay alive. Stay alive. This information is not here to be ignorant and to derive. Gotta derive. Gotta derive. Gotta derive. We can I'm getting nowhere. Sherrill, please help me. Sherrill, please help me, yeah. I was not prepared. Somebody help me, yeah. Gotta be I'm a mathematician, no time to talk. Limit powers and blind man all just come to me. You would assume, now it's over, it's okay. I understand your ignorance. We can try to understand the derivative of ignorance. I'm loving your head, you need to know this around to stay alive. Stay alive. This evolution can add to be ignorant to the right. Gotta derive. Gotta derive. Gotta derive. You can derive. I'm getting nowhere. Sherrill, please help me. Sherrill, please help me, yeah. I was not prepared. Somebody help me, yeah. Gotta derive. I'm getting nowhere. Sherrill, please help me. Sherrill, please help me, yeah. I was not prepared. Somebody help me, yeah.